No semester in technical drawing would be complete without some discussion of scales. And I've gone online to pick up some teaching information that we can use as a guideline, and I'll add to this information as we go. The start of this particular PDF file that I found has to do with drafting equipment from board drafting, because reading scales is the one thing that we really have a tougher time doing via computer. Probably less tough now with a lot of the drawings and things staying on the computer as far as being able to scale them off at full scale. But when we have a printed piece of paper and somebody does print out a plan, just like our field hockey project that we did, which is 1 inch equals 30 feet, eventually that's going to show up on a piece of paper, 11 by 17, which was the style. It's printed out at 1:1 on the 11 by 17, and then you would set with a 1 inch equals 30 scale, engineering scale, to be able to determine lengths and widths that either aren't dimensioned or you just want to verify how things look. This particular one also talks about lead weights, and let's get into the pens, technical pens. We don't want to deal with those anymore. So styluses and T-squares and parallel rules and triangles, 30, 60s and 45s, and adjustable triangles, templates for symbols, compasses, beam compasses, electric erasers, eraser shields, drafting aids. Now we get into scales, and we'll start out looking at an architect's scale. You can see at the top we have two scales. I'm going to see if I can zoom in on a piece of this. So we'll go back to, there we go, that's good. And you see we have a 3/8 inch scale on the top and an 1.5 inches on the bottom. 3/8 scale means 3/8 of an inch equals 1 foot 0 inches. So if this is 3/8, then we notice that the increments down here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each of the increments within each 3/8 of an inch equals 1 inch. If I were to draw a line, let me see if I got some tools here that I can, here's a line tool. We always, on an engineer's scale, start at a whole number on the left. Now, with architect scales, as you'll see further on, we're actually reading the scales from two directions. There's a 3/8 inch scale on this side. There's actually a 3/4 inch scale starting from the other end. So the smaller numbers here indicate our 3/8 scale. So if we go out here to the 10 mark, and I'll just draw a line, and we'll stop right about there. The length of that line, if I measured that on a piece of paper, would equal 10 feet 4 inches. And you might say, well, no, it looks closer to 10 foot 3.5. Really, when we're looking at scales this small, that's about as close as you're going to get. Let's do another line, and we'll start out here, go down to about here. And this line would read 14 feet 3, 6, 7, let's say 7 inches, maybe 7.5 inches. So 14 feet dash 7 space 1/2. 14 feet 7.5 inches. And it really needs to be written out that way when we're doing our drawings or looking at these dimensions. Now you can see on the bottom, on this end of the scale, we have 1.5 inches equals 1 foot. On the other end of the scale, we have 3 inches equals 1 foot, if we were able to see that. So you know that the distance between here and here is 3 inches. If we're reading the scale from this end, you'll see that this is 2 feet. Between 0 and here are 2 lengths of 1.5 inches, or it would read out as 2 feet. You can see now that we have 0, 3, 6, 9, 12. So in between 0 and 3 we have 1 inch and 2 inches and 3 inches. So each of the smaller marks would equal 1/4 inch. If we draw a line from here to, I'll just drop it right there. Now this is 0, this is 1 foot, 2 feet, 3 feet. So it's going to read 3 feet, 3, 6, 7, about 3 feet 7 1/2 inches. And that's about as close as you're going to get to it. These are all done. You can see it shows a triangular shaped rule down here and some flat rules. Normally we see the triangular shape. The 6-sided ones will have 3/32, 3/16 equals a foot, 1/8 inch equals a foot, 1/4 inch equals a foot, 1/2 inch equals a foot, 3/8 inch equals a foot, excuse me, 3/4 of an inch equals a foot, 1 inch equals a foot, 1.5 inch equals a foot, and 3 inches equals a foot. So if we've got a 6-sided scale, on this side we have 1, 2, 3, so we have 4 scales on each side of the ruler. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And some of them you'll also see just a regular ruler on one of the sides. So those are the normal ones you would see. Down here we see some other architectural scales. First one we see is 1/8 inch equals a foot. If we see a line that is here, start at the 12 and work our way back. Whoops, sorry. Too quick on the button. Crap. Let me delete that. It keeps trying to grab it. There we go. And we'll bring this down to about here. You can see in here we have each dash mark in this last foot equals 2 inches. 2, 4, 6, 8, 10, 12. So this would equal 12 feet, 4 inches. Right to this point. Now that's reading from right to left. Now you can see down here we've got on the opposite end of the scale we see the 1/4 inch equals a foot. So if we take another line and we'll come out here, you can see that the 1/8 inch goes all the way up to 93 feet. We're reading the bigger numbers down here, so we have a line that goes from here to say here. We would see that this is 0, 1, 2, 3, 4, 5, 6, 7 feet, and these are 1, 2, 3. So each of these divots is 1 inch. So we'd see that we have 7 feet, 2 inches. Same thing down here. We're looking from left to right, so we're going on the upper numbers. Just like, well, on this one it goes on the lower numbers depending on your scale how it works, but where you see 0, 1, 2, this is 1/2 inch equals a foot. So if we're out here at about this location and we come in, I'll just stop it right there. 0, 1, 2, 3, so we got 3 feet, and there's each of these is a 1/2 inch. There's 3 inches, 4, 5. So it's going to be about 3 foot 5 inches. You can see on this dimension 2 foot 8, 1, 2, 6, 7, 8. Here we've got 2 foot 8, 2 foot, There's 3, 6, 7, 8. Same thing here. 1, 2, 6, 7, 8. So each of these scales represents 2 foot 8 inches. And just let's go down here. Now let's look at the engineer's scale. First thing you notice is no longer are we dealing with increments of 12. We're dealing with increments of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the first scale we see here is a 10 scale. The interesting thing about engineer's scales, using base 10, this scale could mean 1 inch equals 10 feet. It could mean 1 inch equals 100 feet, or 1 inch equals 1,000 feet. So you can see by this example that 12 feet, 1 inch equals 10 feet. This distance from here to here would equal 12 feet. If we just added a decimal place to it, or another digit, and determined that this was a 100 scale, because we're in base 10, we could say this 1 inch equals 100, 110, 120. If we said 1 inch equals 1,000 feet, we could say 1,000, 100, 200, 1,200 feet by using this one scale. So depending on what's written on the drawing, if it says 1 inch equals 100 feet, you would know that this distance, an actual 1 inch distance, would equal 100 feet, and this distance would be 120. And you can see that with this scale, we always start the line at the 0 point and work out, and whatever our remainder is, we just read it off in increments of base 10. Down here on the bottom, you can see there's another one that's probably, let's see if we can determine what this is. It looks like it might be the difference between 60 and 55. So yeah, 55 would be 5, so that would be a 50 scale that we're working off here. So the distance between, you can see how this lines up with the 1 inch. We know that the distance between here and here is going to be 50, or increments of 5, and we'll see it's easier when it's read off the 0 side. Metric scales, same type of thing, except we're working in centimeters, and each of these little divots here would be a millimeter. So there's a centimeter and a millimeter, the big hash mark being the millimeter or centimeter, and then the small hash mark being the millimeter. Or two, however it is, it's the same type of thing. It's a base 10, so it's 1 to 200. We don't get into these too much, but as we look at them further down here, and we don't need to talk about paper and vellum and films, but I do have some other information on scales, and we're going to work on some things. Oops, there we go. More information. Engineer and civil scales such as 1 inch equals 10 feet and 1 inch equals 50 feet are used to measure roads, water mains, topographical features, anything large scale. Architects' scales are used to measure structures and buildings, interior measurements. They're in fractions. They're more accessible when you're talking with carpenters that use the feet and inches and fractions. That's why we deal with that type of scale when we're talking architectural work. And as we look down through here, they talk about the same type of things. I think there's some other information. There's some questions and answers that we're going to go through a little later on that I may incorporate into. I think there we have some scales. Now I have actually photocopied some scales, and I'm going to hand them out to you at full scale, so you don't really need to buy them. I know that budgets are tight, so I photocopied full-size scales. We've got some examples here of some scales. The top one is a 1 inch equals, or a 50 scale, engineering scale. the distance for, so we know that from 0 to right here is 1 inch on this engineering scale. So if the scale, if we read B, let me see, maybe I should go to full view on this thing. There we go. If B is 1 inch equals 500 feet, so if this is 500 feet, this would be 1,000 feet. This would be 2,000 feet, 2,200, 2,300, and looks like about 25. So it would be about 23, 25 for B. 1 inch equals 500 feet. Same scale, 1 inch equals 50 feet. This time on A, this is 50, this is 100, this is 200, this is 300, 350, 360. So that line right up here would be 360 feet long. 100, 200, 360. This is actually the photocopy of the actual scale. So if we had a 10 scale down here on the bottom, C is 1 inch equals 10 feet. So there's 10 feet, 20 feet, 30 feet, 40 feet, 50 feet. So we got about 54.9 feet, something in that range. If you're that close, you know, it's close enough. D, 1 inch equals 1 foot. This is an architectural scale, so we start reading from out here. It's going to be 7 feet, 10 inches, 9, 10. Again, sorry about the phone. Dimension E is 1 inch equals 1 foot. So this one's going to be 4 feet, 4 inches. F, we move to the other end of the scale. This was 1 inch equals a foot. Now we're looking at 1/2 inch equals a foot. And again, with the architectural scale, we're going to start out here. We're going to see that this is 1, 2, 3, 4, 5. Oops, 2, 3, 0. 1, 2, 3, 4, 5, 6 feet, 6 inches. Halfway down that 1 foot line. Looking at the bottom of the scale, we've got our 1/4 inch. So we can come out here and we can see that G is 1/4 inch equals a foot. So there's 13 feet even. If we look at H, 1/8 inch equals a foot. We come all the way out here. I can't really read that. So 4, 8, 12, 16, 20, 24, 26. That'd be 28 feet 4 inches. 28 feet 4 inches. I is 1 centimeter equals 1 meter. So this is a centimeter. There's 1 meter. So everything we come out to the top, we can see that the I is 22 meters. 22 meters. J, 1 centimeter equals 50 meters. Well, if we know that's the case, then this is 5 meters. This is going to be 10 meters. So we take our answer, which is going to be 160 163 meters, and times 5, and I'm not sure what the answer is. It's going to be about 600 meters. So you can interpolate this. If it's 1 inch equals 100 meters, you would just take this. Actually, you could divide it in half is what you would do. 163 divided in half would be 82, roughly 82 meters. It's just a way that you can interpolate those dimensions, and maybe using the 1 to 500 would be easier. So using that information, you can pretty much take any scale that's based on either 1 inch or 1 centimeter and interpolate it into another scale by just using a multiplication factor based on what it is. So it's not hard to do. And As we talk about this in class, I'm putting together, some of this will be used as part of a little quiz we're going to hand out maybe probably on Wednesday. That will include some scale reading. I'm going to put together some of this information and along with your scales that I'm going to hand out and ask you to provide the correct reading for some different line lengths that we're going to show you on the drawing. So keep that in mind. Again, I'll be handing out the scales and we'll be talking about it in class, but if you're familiar with reading scales and doing this type of work, it's pretty easy. I've done it so long that I don't think about it too much anymore, but you can see I struggle with the metric a little bit, but that's just because we don't use it that much in this area. So it's easy to work with if you practice at it a little bit, just like the CAD work. So hopefully this has made some sense to you, and we'll talk about it in class on Monday. Going through the same stuff and looking at different scenarios. Okay, thank you.